Lesson 5.5, the properties of logarithm. Before we talk about the property of logarithm, I would like to talk about finding the value of logarithm function first. Okay, so look at the page 114 and think about number 3. Then you will see that some example a log base 3 81 here. Okay, then how to analyze this value? So first of all, you need to find out prime factorization of 81. So 81 is 9 times 9 and then 3 times 3 and 3 times 3. So which means 3 to the 4th power. Right? Okay. So we temporarily write log base 3 to the 4th power equal to x here. Then now you can switch this to exponential function form, then this become 3 to the 4th power equal to 3 to the x power. So last time we just talk about logarithm means solve for exponent, right? Then now, since base are equal to each other, which means exponent must be equal to each other as well. Therefore, answer x equal to 4 this case. So from here, now we can find out that any expression log base b to the p power, then you can write p. Because they are exactly equal to each other, so this value will be the answer. Okay, then let's think about some example. Also see here, log base 2 5th root 16. Okay, then you can rewrite this log base 2 5th root 2 to the 4th power, because 16 means 4 times 4 and 2 times 2 and 2 times 2, right? Okay, then we all know that n root a means a to the 1 over n power. Therefore, log base 2 5th root 2 to the 4th power, we can rewrite this log base 2 2 to the 4th power to the 1 over 5 power as following this property, right? Then now you can multiply this to exponent based on the property am to the n equal to a to the mn, right? Therefore, this becomes log base 2 to the 4 over 5th power. We just confirm that log base b to the p power is p. So in this case, 4 over 5 is the answer. Okay. Then think about other cases here, such as b log base 8 1 over 64. Okay. Then now, because base is 8, you need to think about this one more carefully. So 64, you can make 8 times 8, 4 times 2, 4 times 2, and 2 times 2, and 2 times 2. So 1, 2, 3, 4, 5, 6. So become 2 to the 6th power, right? But now the base is 8 here, which means 64, you can also rewrite 8 squared as well. Therefore, this means log 8 1 over a squared. That is also possible. I'm going to explain this case after this method, and then we will talk about a little more detail. But now, so this case, you can rewrite this log base 8, a to the negative 2 as following: a to the negative n equal to 1 over a to the n. Then since log a base 8, therefore this is the answer. So this means negative 2 is the answer. But what about another cases here? So we were doing same question but different method here, because sometimes you may have a little bit hard time to find out, 64 is a square. Then we can do different way too. Okay. So in this case, you're finding prime factorization for both 8 and 64. Okay. Then this become log 2 cube. And then 1 over 2 to the 6th power. You can rewrite this log 2 cube and then 2 to the negative 6th power. Since log base and then given value are equal, so you only take out their exponent. Okay, so this case must this over this. Therefore, negative 6 over 3, there will be negative 2. You can do this way as well. Okay? So what about f? F is log base 7, negative 49 here. Right? Okay. So what do you think? Unfortunately, in this case, no solution, because log any base x must be bigger than 0. It cannot even be equal to 0 either. Therefore, since this is the negative 49, it will be no solution. Okay? So next video, we contain more property and then solve other more problems.